eclipse is today.
Yeah, today's the eclipse, isn't it? Like right about now, isn't it starting?
Yeah. I'm gonna go use the restroom.
All right. So here we have, we're supposed to find on this question, this is number 13. Oh, I'm sorry. Here, let's do this. My pencil's not charged, and so I'll just run through roll. Yeah. While my little pencil charges, I'll just do roll real quick.
So I like new iPad.
It's good. All right, let me run through roll here. So Myra
Here.
Aguilar is here, and Christian Almaraz is here, and Eduardo Almaraz is here, and Sydney Armenta, and Miranda Arroyo is here, and Dynasty Brown. Dynasty. All right, remind me. Jasmine Carrion. Jasmine is not here. No Jasmine. So third day of this. All right, and Aliha Caceres. Aliha Caceres. Okay, Chumki is here, and Chunky, yeah, that's right. And Wendy Crisco is here, and Lawrence Gaspin, yeah, Lawrence. Jonathan Ham, Zong Her,
Here.
Amy Knight is here, and Melanie Kong, and Daisy Lopez, and Evelyn Macias. Evelyn, right? Evelyn. Gilberto Maldonado is here. Adrian Martinez, Julieta Mendez, and Adam Mendoza. Adam, no Adam. And Armando Mora. Armando, right? And yeah, say it one more time. Ajane. All right, Ajane. I've got another Ajane. Okay, in my other class. Yes, I should be able to do that. Benjamin Moosman.
Here.
All right, and Marcos Rogel, and Nancy Ortiz, and Amanda Poole, and Eric Rodriguez, and Rudy Salamat. Rudy? Am I saying it right? Raid is actually the formal first name. Raid Salimat, not here. Okay. And Crystal Sanderson is here, and Jeffrey Simons, Luke Smith,
Here.
and Ulysses Solorio, and Dana Swain, and Juan Tepek. One is here. Shawnee Tao is here. Is it Blong Tao? Blong Tao is here. And Jose Tortolito is here. John Toscano is here. Brian Vang is here. Dustin Wallace is here. Gao Chi Yang, no. And Vanessa Yang is here. Garland Zimmerman is here. Luis Zuno. Luis Zuno, no. And Lauren Rodriguez is here. And Jeffrey Martinez is here. And Nicholas Garcia is here. Davin Hernandez is here. Kayla Trevino is here. B. Tao is here. Chinuj Vang? Chinuj? J7. Press that out. Chinu. All right. Jasmine Nagy. And Sabrina Juarez. And Annaline Giron. All right. Oh, you go by Anna. All right. All right. Did I miss anybody? Roberto, I missed you. Are you here just to? Do you need to say something more? Oh, you need to give you're gonna write your R's back there or something?
No,
at him right now.
Gotcha. So we'll look later. Don't pay attention to the man in the back. This is like Wizard of Oz. Don't look at the man behind the curtain. All right, so off we go then. My pin should be charged and we should be ready. So, what is the problem? Wait a minute, I'm having a pin problem here. Where's my pin doing nothing?
Maybe it's not charged enough.
All right, we're ready now. All right, so they want you to find this little a over here. So, this little a. So find the little a. This is problem number 13. This is section 1.2. Problem number 13. So, how can we find that little a, that side of the triangle? So remember the last thing we learned was the whole SOHCAHTOA thing, right? Remember SOHCAHTOA? SOHCAHTOA. Yeah, so now I know a little more fresh. I will give you a 3x5 card you can use on exam number 1. So that's all you're going to get. It's a 3x5 card.
That's all I need.
But that's a lot. Write anything you want on both sides. So I definitely write SOHCAHTOA on both sides of the 3x5 card. So, how can we use the SOHCAHTOA thing to find little a? So what you want to ask yourself is, what relationship could I set up between this angle, the little a, and this number? Why did I pick those 3? Well, those are the only 3 things I know up there. I don't know this side, for example, no idea. Don't know this angle, for example, no idea. So I'm just circling the 3 things that I have a number or letter for. You with me? This angle, this letter, this number right here. So I know these 2 sides. Well, I don't know this side, but I have a letter or a number on those 2 sides and this angle. So ask yourself, what's the relationship that connects this angle to these 2 sides? So from this angle, this is the what? Opposite side, and this is the adjacent side. Remember how the opposite, adjacent, and this is the hypotenuse, right? The hypotenuse is always the longest side. It's the side across from the right angle that doesn't touch the right angle. You with me? See how the other 2 sides, they're both hitting the right angle, aren't they? But the hypotenuse is the longest side. He's across from the right angle. So, with that in mind, what relationship over here involves opposite and adjacent? Let's go through it. This stands for sine, opposite, and hypotenuse. This stands for cosine. It says cosine there. Adjacent and hypotenuse. I don't want either one of those, because they both say you need to have the hypotenuse. I don't got the hypotenuse. I don't know anything about the hypotenuse. I don't want that. But then come to this one. What's T stand for?
Tangent.
Tangent. And it's saying, hey, tangent, you know what tangent is? It's O opposite over A adjacent. That's the one I want. So let me grab that, bring it down. That means the tangent of any angle, that'd be 35 degrees, the tangent of the 35-degree angle is equal to the opposite side, which is the little a, over the adjacent side, the 330. Are you with me? Everybody see that? Tangent of 35 is little a over 330. Here, write that a little cleaner here. Everybody see how I came up with that so far? How'd I know to use tangent? Where'd that come from? Why didn't I use sine or cosine? Because I looked at my triangle and I said, well, look, I've got the opposite of the 35-degree angle, and I've got the side adjacent. Adjacent just means next to, like your neighbor's next to you. The 330 is next to the 35, and the little a is opposite, across from the 35. and I don't have the hypotenuse. So I didn't want to use this one or this one because they both involve the h. The hypotenuse, and I don't have that. But this one's perfect. Tangent is opposite over adjacent. Okay, so you guys have your calculator? I didn't bring mine. What's tangent of 35 degrees? Somebody have that? Anybody?
0.4738.
One more time?
0.4738.
0.4738. Thank you. Anybody else getting that same number? Verification? Different? Yeah, so yours is different. So one of you is in degree mode instead of radian mode.
Am I supposed to be in degrees or radians? Am I supposed to be
It looks like you're in degree. D. 0.700. Anybody getting that?
Yeah, I got that.
Okay, yeah, so your calculator must be in radian mode. Yeah, double check. Yeah, always double check your mode. And how do you know what we need here? Well, this one has degrees on it, right? So we're supposed to be in degree mode. Yeah, it's good. It's good that we're double checking for the modes. It's good to learn to do that because you don't want to do that in a test. So double check. Make sure what mode you're in when you're there. So we good to here so far? Now I'm supposed to solve. This is a little equation. I want to solve for the little a. How do I solve? It's like solving for an x, right? How do I solve for that little a? How do I get that little a alone? Multiply by that 330, right? Multiply both sides by 330. And so little a will equal, I don't know what that is, 200 something.
200 and
What is it? 231? I don't know how many decimal places they want, whatever they want. Just give them what they want. They tell you in the blue line. Why don't you give me, what is it, 231.06? 231.06? Okay. 231.06. Is that good? So we found little a. We found out how long that side would be. By just having, it's interesting, isn't it? By just having an angle and the bottom side, we were able to find the other side of the triangle by using the tangent relationship. Tangent is opposite over adjacent. Is that good? Questions on that? All right, I'm going to move on. All right, so try that one. They want you to find that little c there. So let me write out SOHCAHTOA for you so you want to. So do what I did last time. Look at the angle they're giving you. This time they're giving you the angle on the right. Look from his perspective. Don't say it out loud. Give everybody a chance to think about it. But from this angle's perspective, you have this side and you want that side. So ask yourself, this side and this side, what are they? Opposite, hypotenuse, adjacent. First get straight what those two sides are from the 34's perspective. And then go over and see which one you need. The SO, or the KA, or the TOA. Roberto, they're making you do different hours for each class?
Oh yeah, it's all over the place.
Okay. So for 4A, you're there Thursday and Friday?
Yes.
Couldn't they really just come any of those times, though, and you'd help them?
In theory, it
He's
really
like
depends on the amount of students. For example, if I have a 4B student, I can't exactly be helping 4A as easily.
Right.
So that's why they try and schedule it based on section.
Gotcha.
But I would say feel free to try it.
Yeah, your priority will have to be whatever the group is, but yeah, gotcha.
Priority,
Yeah, so there's Roberto's hours back there for all the different classes I'm teaching that he's covering. So there you guys are for 4A. But yeah, you could come any of those hours. You just won't be his first priority if you
They'll
come other
probably
hours.
change by next week, I think.
Oh, they're going to
I'm
change?
still working on adding classes because Fresno State starts a week
Oh.
later. So I'm still working on adding some classes.
Oh, that's right.
including some.
You start
So
tomorrow.
It'll probably be amended by next week, but for this week, this should be what works.
Okay, thanks. All right, so look at the 34. This side is what? It's opposite. And this is the hypotenuse. You with me? This would be the adjacent side, but they didn't give us that. right? So from the 34's perspective, this is the side next to him. You know, you might think, wait, mister, both these sides are next to 34. Yeah, you're right, but this is the hypotenuse. So we don't call it adjacent, right? This is these two sides are next to 34. This is the adjacent, that's the hypotenuse, and that one, therefore, is the opposite. So what we have is opposite and hypotenuse. So which one involves opposite and hypotenuse? Sine, right? The sine of the angle of the 34 degrees is opposite over hypotenuse, right? So the sine of 34 degrees is 24 over c. You with me to there? Is that good so far? Everybody seen how I came up with that? Right? I looked and how did I know to use this? Why am I using the sine, the so, instead of the to this time? Because I have opposite and hypotenuse. Last time I had opposite and adjacent, right? Look back. See? This one we had opposite and adjacent. I didn't have hypotenuse. See the difference? But this time it's opposite and hypotenuse. So that's sine. So there we go. Somebody have the calculator. What's the sine of 34? Anybody?
0.559.
What is it?
0.559.
0.559. Somebody else getting that? No?
42.9.
It's in
No.
degrees, I got what you got.
Yeah, it's in degrees. We're in degrees, so that sounds right. It looks like to me. 0.559. And nobody else is. Oh, you said you did. That's right. Yeah. So 0.559. Good. Okay, we good to there now? On that, if you have any trouble with the calculator, grab me after. Just take 10 seconds to help you out with that. Okay, now we're supposed to solve this little equation for c. Let me bring it over here. 0.559 is 24 over c. How do you solve that for c? Yeah, multiply by c, huh? Whenever you have a denominator, whatever's under the bar, you multiply both sides by that, right? Like, look back over here for a minute. We had the 330 under the bar. We multiplied both sides by the 330. So whether it's a number, letter, whatever it is, doesn't matter. Whatever's under the bar, multiply both sides by that. This time we have a c under the bar. So I'm going to multiply both sides by the c, right? And then what happens here? These cancel. And I get c times 0.559 is 24, right? The c's canceled over here. Everybody with me on that? So I multiplied both sides by c's. They canceled here. And now I'm trying to get c alone. What's the last step to get c alone? So first you get rid of the fractions, right? When you got fractions, you get a number, letter, whatever below, you multiply both sides by that. Here we go, no fractions. Now, last step to get c alone is you divide. Everybody knows from here, right? Divide by the 0.559. The answer should be something like 40 something.
42.9.
42.9? So that'll round to, they want you to round it to the nearest whole number. We'll say 43. 42.9 rounds to 43. Is that good? We were able to find a side of a triangle, the hypotenuse, based on an angle on another side. Questions on that? Are we good? So I need something other than your poker face again. I need a yeah or I need a no. Either one's fine. I need to know whether to slow down and say it more and talk more about it or keep on moving. All right, well, say something. If you're getting confused, say something so I can, because I'm sure you're not alone. So I can say. All right, so they're telling me tangent of theta is 5.3885. Like that.
You showed us the answer.
Okay. What are we going to do? Let me, tangent or sine or cosine, they are functions. A function is like a toaster. Roberto, did you need to say some more?
No, it's fine.
Okay. A function is like a toaster. Let me just write toaster. What do you put in a toaster? Do you put in, you put in stuff like bread or frozen waffles or whatever, and what comes out is toast.
Toast comes out of waffle.
Toasted waffles, whatever, right? I know that seems silly, like, yeah, right. In other words, you don't put toast in a toaster. Toast is what comes out of a toaster, right? I'm trying to be really clear. There's what you put in and what comes out, because that's what they're messing with us in the tangent question here. So I want to get that really clear. They're switching inputs and outputs is what they're doing. They're being tricky. So I want you to see it from the toaster perspective, right? If I said, hey, the toaster of something, and it came out toast, well, then the answer would be, well, bread went in. That's what they're saying here. They're saying, hey, we put something in the tangent machine. That's what functions are. Sine, cosine, tangent, everything. You move on into calculus, it's all functions, which means you put stuff in, you get stuff out. So this is the input. Well, how does sine, cosine, tangent, how do they all work? You put in an angle, you hit the button, out comes an answer, right? So this is the input, which is always an angle. And what comes out, the output, is some kind of answer. So you put in an angle, you get out an answer. That's how sine, cosine, tangent, that's how they all work. All the trig functions. Secant, cosecant, cotangent, all of them. You put in an angle, you get out an answer. We can, if somebody gave us an angle, we can hit the button and get an answer. So we did back here, right? We put in 34 degrees, hit the sine button, got out an answer, 0.559, right? So what? Well, they're telling you the answer, aren't they? They're saying, hey, somebody put in some angle, and the answer was 5.3885. What was that angle? They're asking us to do it reverse. You see that? They want us to find what was plugged in. So how do you do reverse of tangent? Inverse tangent, right? Y'all getting me? It's that inverse tangent button on your calculator. How do I know? Because they're reversing things. They're giving me the answer instead of the plug-in, the angle. So take your calculator, hit inverse tangent of 5.3885. Make sure you're in whatever mode they want, degree. On this one, see it says degree in the blue line there. So make sure you're in the degree mode, and it'll tell you what angle was plugged in to produce that answer. We're doing it backwards. So what's that angle? Oh, actually, I already answered it right there, 79 degrees. I did this one earlier ahead of time. 79 degrees. You guys getting that? Does that make sense? Do you see how I know I'm supposed to do inverse tangent instead of regular tangent? It's because they're not giving me the input. They're giving me the answer. So that's backwards, right? When they give you the answer. They're asking you to do tangent backwards. Good? So it's like an inverse toaster. What would an inverse toaster do? You put in toast, right? If a normal toaster put in bread, get out toast, then an inverse toaster switches those. Put in toast, get back bread. Right? You guys with me on that analogy? That's what we're going to do a lot of this in the class. So it's good you get that straight. So an inverse, when would you use an inverse toaster? When would that work? Come in really handy when you stick in the bread, you're making breakfast, pop up the toast, and you think, oh, I wanted to have eggs, I forgot. And you think, oh, no problem. I've got my handy dandy inverse toaster from Walmart, right? Sorry, I'm being really goofy, but I'm trying to make the analogy work for you. You'd stick your toast in the inverse toaster, push down the lever, turns it back into bread. Right? Inverse as the opposite, stick it back in the bag, it's all good. Right? Then we're not going to do that. There's no real need of that. But that's what an inverse tangent does. You getting the idea? It switches inputs and outputs. So a normal tangent, you put in angles, you get out answers. An inverse tangent, you put in answers. You get out angles. See what I'm talking about? It reverses the inputs and outputs like any inverse anything. All right. Radian mode. So they're saying tangent of theta is 0.2606, and they want theta. So that means you're going to have to do inverse tangent, right? Because 0.2606, that's an answer, isn't it? We're putting in an answer. You put answers into inverse tangent, get back angles. It runs it backwards. So I didn't, and they want radians. See how I'm seeing right here? Radians. So make sure you're in radian mode. Somebody have an answer there? 0.2549. They said 4 places. Yeah. Anybody else getting that? Yep. Okay. Looks good. Rounded, that's rounded and everything? Rounded to 4 places?
If you would round it, then it would
Yeah,
be
2.255.
Oh, because it's 49, something bigger than 5? What is it, 497, 496?
Oh, no, that's right.
Oh, that's right, yes, 492.
492, yeah, so then we'll just leave it at 0.2549. Right, remember, if that extra digit, remember, when they say stop in 4 places, if the next digit's 5 or more, you go up, otherwise leave it. So 0.2549. There it is. Good on that. That is an angle, by the way. It's not degrees, it's a radian angle on that. All right, I'm going to keep moving. All right, so 5 plus sine squared of 50 plus sine squared of 40. Okay, on the next exam, well, the first exam we take, next week on Wednesday, practice exam on Monday. A week from today, we'll be taking the practice exam, so you'll see exactly what I'm talking about. There'll be, is it 9 questions? I think it's 9. There's 25 altogether. 9 on the first part that are no calculator. So I'll pass out, the exam's going to be in 2 parts. So the first part will be no calculator at all. Just like some of these say do not use a calculator. It'll be no calculator at all. It'll be like 9 questions. You'll see exactly what I mean on Monday. On the practice exam, it'll be identical. So you won't be surprised when Wednesday hits. You'll know what kind of questions. It'll be these kind of questions. The ones you don't need a calculator. So you do have to really do it. So pay attention. They mean it. Don't just say, well, hey, I got my calculator, so I can whip it out. I mean, you could do that and get through the homework, but homework points are worth nothing. Test points are where it's at, right? Like we talked about on day 1. So you got to learn this the real way. So how can you do that without a calculator? Well, you got to know a couple of properties. They're hinting at you for properties. First off, to remember the property we learned last time. Remember what we learned about cofunctions? What did we learn about cofunctions? They're complementary. And what does that exactly mean? So we have like sine and cosine, right? Or secant and cosecant. And tangent and cotangent. What's with all these co things, right? You got the function and the co, and the function and the co, and the function and the co. What's the deal with them? What does co stand for? Stands for the word complementary. Remember that? Complementary means 2 angles that add to equal what? Complementary angles add up to equal 90 degrees. They make a right angle. Remember, supplementary makes 180. We're not doing that, but remember that from geometry. 2 angles that are supplementary are angles that add up to be a straight line, 180 degrees, right? 2 angles that are complementary make a right angle. They add up to be 90. Okay, so what? Well, that's what the sine and the co is the beginning of the word complementary. That's what they're saying. Cosine means it's complementary to sine, meaning if you take an angle that adds up to be 90 with it, they're going to be the same thing. Meaning the sine of, pick whatever you want. The sine of 70 will equal the cosine of 20, or vice versa. The sine of 20 will be the cosine of 70, because they had to be 90. You with me on that? I could pick any 2 angles. I could say sine of 30 equals cosine of 60 degrees. Or I could switch that. I could say sine of 60 will equal the cosine of 30. Either way, whatever. Sometimes I write the whole word sine. Sometimes I do the 3-letter abbreviation. It's the same thing either way, right? You guys with me on that? If you have 2 angles that add to be 90, add to be a right, you can plug them into any function and his co, and they'll be equal. That's what it means. I could do 10 and 80, or 80 and 10, whatever. They're equal with the co-functions. Okay, so what? Well, look at this. What are you thinking? They're hitting on the co thing. That's what you need to realize when you look at that question. You need to go, 50, 40, that's 90. They're doing a co thing. Right. They're doing a co thing. Sine, pick either one you want. Sine of 40, that's the same as what? So if I put sine of 40 right here, sine of 40 is the same as the cosine of 50, or vice versa, right? So what? Well, then sine squared. These are squared. The squares don't change anything. So cosine squared of 50. You with me so far? And then this one, just bring down. There's 2 steps to this logic. We just did the first step. I'm running out of room. Come on. Let me rewrite this a little bigger. So 5 plus sine squared of 50 plus, and I'm going to make this cosine squared of 40. Comes right there. We good? Am I losing you yet? All right, you guys with me? So I just replaced that sine squared of 40 with cosine squared, not a 40, it's supposed to be 50, huh? I'm messing up. What happened? I thought I understood this. Mr. Heron's doing something crazy. Yeah, so far so good, right? Because the sine of 40 is the same as the cosine of 50. Complementary angles, complementary functions, right? Now you might say, well, yeah, but why did you just do that one, and why didn't you do the other one, Mr. Heron? I could have, but I have another plan. So I'm just going to do one of them. I'm just going to replace this one. You could have done the middle one instead. It doesn't matter, but don't do them both. Why? Because now I've made them the same angle. That's why I only messed with one of them and left the other one unchanged, because I wanted to make them both 50 degrees. Or you could have made them both 40. Right? I could have changed the middle one from sine squared 50 to cosine squared 40, couldn't I? Either way, I've made them both the same angle. Well, so what? Well, what's that other identity we learned? They're hitting on 2 identities here. Do you remember? What's sine squared plus cosine squared of the same? If you have sine squared of any angle theta plus cosine squared of the same angle, these must be the same theta. It always equals 1. So once I've made these bad boys the same, I can go, you're 1. So that's all 1. 5 plus 1, 6. That's how we can do it without a calculator. And that's what you'll have to do next Wednesday. Well, Monday for practice exam and Wednesday for the real points. So you'll have to do that without a calculator. You have no calculator in those first 9 questions. Does that make sense on that? You put it on a 3x5 card, though. You will have your 3x5 card. Write whatever you want in there. Write down sine squared plus cosine squared is 1. Write down the complementary function stuff. You know, you'll have that on your 3x5 card for both parts. You just won't have a calculator for part 1. Questions I can answer? Is that good? All right. All right, so this is number 19. I'm skipping 18. I'm going to come back. So here's number 19. They're giving me a little triangle. They want me to find out how far across that lake. So, you know, you got 510. So this would be one thing you could do to figure out, you know, some real life shapes. You walk off 510 yards here, 5 football fields, 510 yards. You measure this angle, 34 degrees, and then you say, how far across that lake, how far is that other side? So this is the SOHCAHTOA thing that we did a few minutes ago. Try it one more time. So you need to look at the relationship. So take a look at that angle right there and ask yourself, you know, don't say it out loud, give everybody a chance to try it on their own. Figure out those other 2 sides. Are they opposite, adjacent, hypotenuse? What is this? And don't say it out loud. What is that? Find out what they are related to the 34. From the 34-degree perspective, are those guys same, opposite, adjacent, hypotenuse? What are they? And then once you got that, you'll know whether you need the SO, the CA, or the TOA, based on what those are. All right, so the A and the 510, what are they from the 34-degree perspective? Opposite and adjacent. This is the hypotenuse, but we don't have that. Good? So that's opposite and adjacent. So which one of these 3 relationships involves opposite and adjacent? The TOA. Tangent of 34 degrees, of 34 degrees is opposite over adjacent. right? So bring it over here. Tangent of 34 degrees is opposite, so that'd be the little a over the 510, right? Good there? Bless you. What's tangent of 34? Somebody have that? Was that the same one we did a minute ago? Excuse me.
Let's see.
I thought we just did tangent of 34, didn't we? No, 35. Oh, I was off by one. All right, so what's tangent of 34?
12.674.
Are we sure we're in the right mode?
Yeah.
Degree mode, okay. Anybody else getting that same answer? That good? All right. And now we got to solve for little a. How do we solve for little a? Multiply by whatever. Remember, whatever's in the denominator, whether it's a number, letter, whatever, multiply both sides by that, right? Remember that from your algebra days, your glorious algebra days. So we've got the little a. So I'm looking at, I don't know, was it like 300 something? High 200s, 300?
344 if you round up.
244? No, I think it's got to be bigger.
I said 344.
Oh, 344?
That's if you round up.
344. It says round to the nearest whole number. Is that rounded to the nearest whole number?
Yeah.
344. Good deal. We got it. Is that good? Yeah. It doesn't really, I wouldn't, it doesn't matter in the middle. Just use this, when you're in the middle of a problem and you're not yet to the last step, use as many digits as you can. I would just let the whole thing sit on my screen. Yeah, I'm glad you brought that up. Good question. Yeah, when you first hit 1034, you get 0.674. Honestly, I would just leave the whole thing right on my screen. It's more accurate that way. When you're in the middle of a problem, you want to try not to round in the middle if you can, because that'll throw off things later. Just let the whole thing ride. Just go times 510 right then. You get this answer and then round the final answer. If you can, just round the last one. It's more accurate. All right, but you could round if you want. Let's take a look. So they're saying f of pi over 6. Don't use, oh, and they say type an exact answer. Yeah, I guess we have to. Okay. All right, so let me give you a couple of facts. No, well, first off, let's take that pi over 6. See that right there, pi over 6? That's, is that degrees or radians? Pi, it's an angle, right? It's an angle. Is it degree or radian? How do you know for sure? It doesn't have a degree symbol. Plus it's got the pi. Right. So let's change that to degrees, just be easier for us. So what is that in terms of degrees? How do you change from radians?
30 degrees.
Yeah, remember the pi you replace with 180. So that's 30 degrees, isn't it? 18 divided by 6. 6 goes into 18 3 times. We good there? 30 degrees, 180 divided by 6. Remember, you just replace the pi with 180, because pi is 180. So you want to remember that you put it on your 3x5 card. That's always how we change. Pi is 180. All right, so this is 30 degrees. So they're wanting me, now what is this? F parentheses pi over 6, and now I'll replace that with 30 degrees. That means plug into the toaster, right? That's function notation. That means plug into the toaster. Here's the toaster. F of theta is 2 cos theta plus sine 2 theta. This is function language. This is function notation. This is toaster, right? That means this is a toaster, and anything you stick into the toaster goes there and also goes there. It goes to those two places. You with me? So if I put into the toaster 30 degrees, that 30 degrees will slide down right there and right there, won't it? You with me? That's function language. Plug into the toaster. All right, so that means we have 2 cosine 30 plus sine of 2 times 30, which is 60. So 2 cosine 30 plus sine of 60, effectively. We good so far? Right, I'm not going to actually use that here, but that is true. They are complementary. Everybody good to this point? So all I've done right now is I've just changed pi over 6 radians to 30 degrees, and then I'm plugging 30 degrees in for theta everywhere. Just plugging into the function. So I've got 2 cos 30 plus sine 60. Good so far? Now, you can hit the buttons on your calculator, but that's not going to be what they want. They say exact answer using radicals. They want like a square root of 3 kind of answer. They don't want decimals. So we're going to have to give them an exact answer. That's what they mean by do not use a calculator. This is what you're going to have to do in the part 1 of the exam next week. First 9 questions. This would be one of the ones I would give you without a calculator. Why? How do we do that? Well, there's going to be a few values we memorize. Let me just give them to you right now. Would this be a good way? Yeah, okay. Let me just give you a few of the values. In fact, let me just go to a fresh screen to do that. Let me, I'm going to give you 3 values that happen within 90 degrees. So, is that a good way to do it? Yeah. 30, well, yeah, Heyman and Hahn had to do it. Let me do it this way. So if you have an angle like that, I'm going to give you 3 positions. This would be the first one. This is the middle one. This is the bigger one. This is 30 degrees. This up to here is 45, and all the way up to here is 60. I'm going to give what we do, how we do trigonometry for the angles, is we memorize the big 3, and the rest we use our calculator for. It's basically what we do. So you're going to want to memorize or put on your 3x5 card, know the answers without a calculator, for 30, 45, and 60. Anything else, we just use our calculator. 67 degrees, hit the buttons on the calculator. Nobody memorizes that. 34 degrees, hit the buttons on your calculator. Nobody memorizes that. But 30, 45, 60, you want to have memorized. Well, how do you memorize them? Well, basically, the way it works, I'm going to give you I'm going to give you 3 numbers. Square root of 1 over 2, square root of 2 over 2, and square root of 3 over 2. Kind of being a little scribbly there. Okay, so those are commas. I'll just separate them that way. Small, it's like ordering a soda or something. Small, medium, and large. Square root of 1, square root of 2, square root of 3, all over 2. Small, medium, and large. You with me so far? That's what you're going to want to put in your, well, you'll put in something even bigger on your 3x5 card, which we'll get probably Wednesday. So now, what am I talking about small? Well, first off, do you realize, and square root of 1, that's just 1. Huh? This is really just a half, isn't it? But I'm just writing it with the square root at first so you see the pattern. Just making the pattern obvious for you. Square root of 1, square root of 2, square root of 3. Just as I count. 1, 2, 3. All over 2. But square root of 1 over 2, that's really just a half. Nobody would really say it that way in the end, right? It's really just a half. Okay, so what? Well, see this dot right here? And of course, in this one and this one. Think with me about these dots. This dot from the origin, from right here at the origin, is over a long ways, only up a little ways. He's over a large amount. He's up a small amount, isn't he? The one in the middle, he's over a middle amount, up a middle amount. He's over a medium amount, up a medium amount. He's going to be using these medium values. See what I'm doing? And then this guy, he's over only a little bit, but he's up a lot. He's only over a small amount, and he's up a large amount. Small and large. I'll get to the exacts, but that's what I'm beginning to indicate. You with me? You look at that dot, and you think, any of those dots you're at, and you think, well, how far over is that? How far up is that? Small, medium, or large? How far over the x coordinate and the y coordinate? How far over? How far up? The x is always the cosine, and the y is always the sine. Now, I'll give reasons for this later. I know you're thinking, wait a minute, we did the SOHCAHTOA. Sine is opposite over hypotenuse, and cosine is adjacent. I know. That's true also. That's another way of saying the truth, and I'll connect that all up for you later. For now, let's just get comfortable with what we're talking about. So at any dot, you look at how far over it is and how far up it is to get to that location. The over, the x, is the cosine. The up is the sine. and you do small, medium, or large. So, for example, let's put this all together now. What if somebody, just draw a little right angle there, what if somebody said, hey, what's the sine of 30 degrees? Here's what I would do. I would look at my little arc, and I'd go, okay, I got my 3 dots, right? 30, whoops, 45 in the middle. 30, 45, 60, right? So which one do you want? You want 30. Okay, 30. How do I get over to 30? Well, I go over a whole bunch, over a large amount, up a small amount to get to the 30, right? And sine is sine the, no, it's the y. Sine is the y. So what's the y? Small. It's the small answer. It's the half. Small. Done. What if they'd asked for cosine of 30 instead of sine? Oh, you want cosine? Cosine's the x. Cosine's how far over. Sine's how far up and down. Cosine's how far over. So, well, how far? To get to 30, do you go over a lot? Yeah, you do. You go over large. What's the large answer? Root 3 over 2. That's what it is. Root 3 over 2. You tracking with me? So you just find that spot, 30, 45, or 60. You find how far over to that dot will be cosine. How far up will be sine. And we're talking small, medium, or large. So for 30 degrees, you go over a large amount. So cosine is the large of the answers. 1, 2, 3. It's 3, the root 3 over 2. The up is the sine. That's a small amount for 30 anyway. It's a small amount. It's going to be the small answer, half. Let's try another one. See if this is making sense for you. So try this on your own, guys. Try the sine of 45 degrees. So look at that little picture. Draw yourself your own right triangle if you need to. Find the dot. Don't say it out loud. Give everybody a chance. Sine 45. Give you a second. Locate it. Here's 45. So draw how far over, how far up. Okay, so for a 45-degree angle, to get to the dot, you go over a medium, up a medium. 45 is right in the middle. Notice that medium goes with medium, and small and large always go together. You never have large with medium, or small with medium. You with me? Medium just goes with himself. Medium with medium. The 45. He's medium, medium. Whereas the 30 and the 60, they mix small and large, don't they? So for the 45, you just go, oh, 45 degrees? You're talking about a 45-degree angle that's over, that's right in the middle. That's 45, because that's half a 90, isn't it? 45 is half a 90, right? This is 90 straight up. And this is 0 degrees here. Going from 0 to 90, aren't we? So 45 is right in the middle. It's halfway to 90. So it's going to be over, medium, up, medium. What's medium? Well, it's 1, 2, 3. So medium's right here. Root 2 over 2. I don't even need to really think about whether it's over or up. But it is sine. Sine is up. So it's up, medium. But even if it, what if they ask me cosine of 45? Same, because that one's the medium one. He's right in the middle. Doesn't matter if we're talking over or up. It's the same. You with me? Because it's over medium and up medium. Cosine is over, sine is up. Is that making sense? Let's try another one. How about, let's do sine of 60. So try that one on your own, see if you can get that answer. Okay, so 60, starting from the origin. So here is a 60-degree angle. So right triangle, 60-degree angle, over and up. So you're over for a 60-degree opening for a 60-degree angle, which is getting close to 90. It's 2/3 of the way to 90, right? You go over a small amount, up a large amount. Over a half, up root 3 over 2. The large number, right? Cosine is always over. Sine is always up. Always. That's going to become the definition of cosine for us. Cosine is x value. Sine is y value. So cosine, so what do they want? They want sine. It's the large root 3 over 2. If they'd asked me for cosine of 60, that'd be the small, that'd be the half. We good? Is that making sense? So that's an exact value. Now, you could get that in your calculator. You could hit sine of 60 on your calculator. You get some decimal, which is what root 3 over 2 is. But whenever they asked for exact, they don't want a decimal, because decimals we round. They're not exact anymore, right? This is exact. So whenever they say exact, they mean the roots, the radicals, not a decimal. So let's go back to our question then. If you're good with that, stop me if you want to talk about it. Going back over here. So then what is the cosine of 30? Well, we just did it. Let's go back. Cosine of 30, here it is, root 3 over 2. Cosine of 30 is root 3 over 2. So I'm going to put in here root 3 over 2. And here, sine of 60, whoops, I'm supposed to write sine there. Sine of 60, what is the sine of 60? Well, it's also root 3 over 2. Right? Sine of 60. So this is also root 3 over 2. You with me? So cosine of 30 became root 3 over 2. So did sine of 60. No surprise, by the way, that they're the same. You're not surprised, are you? Those are complementary angles. 30 and 60 make 90. Remember, we already learned that, right? Two complementary angles, complementary functions, going to be the same. Of course. All right, so what's that? What happens with 2 times, parentheses, root 3 over 2? What's going to happen here? Going to cancel, right? Because that's 2 over 1. Cross cancel. You with me? So that's just root 3. So bring it up here. So that's just root 3 plus root 3 over 2. There we go. Oh, I think they want you to put those together.
Yeah.
They might take, I mean, I'd be fine that way in a test. It's multiple choice. Oh, yeah, you will need a Scantron. Yeah, let me mention that. Yeah, it's going to be multiple choice. So you're going to need 2 Scantrons for 5 tests, 10 plus the final. So 12 Scantrons for the whole semester. If you want to just grab them all. Number 8A2E. That's the typical one. That's the tall, thin, 50 front, 50 back. Just the most typically used one over at the bookstore, Target, Walmart, wherever. You need 12. You need, 1 for the practice exam. I'm going to actually give you the practice exam, throw it through the Scantron machine, and give it right back to you so you know where you need to practice. That'll just be for you on Monday. That's what we're going to do right in here. We'll take it for an hour. I'll run it through the machine and pass it back. I won't even look at it. I'm just giving it back to you so you know your strengths and your weaknesses, what you need to get ready for the real exam, and then the actual exam on Wednesday. You'll need one that I will look at and record. So 2 for each exam, 5 exams plus the final, 6, 2 times 6, 12. So anyway, to here, that's fine with me. Multiple choice test, they probably will put those together. So you'll need to grab the option where they've combined them. So let's do that. How do we combine those 2 into one fraction? Put this one over 1. Whenever you have a whole number that's interacting with a fraction, put it over 1. So that it looks like a fraction. And then we got to make denominators the same. So multiply top and bottom by 2. We get 2 root 3 over 2 plus root 3 over 2. Good so far? Am I going too quick? Multiply top and bottom by 2. Why? To make these have common denominator. And now, put them together. So remember your algebra rules? Remember the root rules from algebra? That's the stuff I'm glad to help you with. That's what you need to master to make it in pre-calc and calc. So 2 root 3 and root 3. Remember you just add the numbers in the front? 2 roots of 3 and 1 root of 3 is 3 roots of 3 over 2. There's the final answer. Yeah, that's definitely how they would have it. Yeah?
We have a tangent instead of a cosine in the front, like 2 tangent theta.
Right.
Do you still
Oh, yeah. Yeah, how would we do the whole exact thing? I see what your question is. Yeah, good question. How would we do tangent? What if they'd said tangent of 30 or something? Right? I just gave you all the rules for sine and cosine. That's all I gave you for exact. How would you do tangent of 30? And if they want an exact. Good question. What would I do? Excellent. Remember, we learned the definition. What is tangent? Sine over cosine. So you would go back and go, oh, well, that's just sine over cosine. Go get the sine of 30, which is somewhere, a half, and the cosine of 30 over root 3 over 2. So you go, well, that's a half over root 3 over 2. That's sine over cosine. That's a 1 there. 1 half over root 3 over 2. And now, remember when you have a fraction in the bottom of a fraction? Remember from algebra? Flip it up, because it's really dividing by that bottom one. And dividing, you flip the fraction on the right. So it would be a half times 2 over root 3. So I just took that and flipped it upside down. And then these would cancel. So the answer would be 1 over root 3. Then you have to multiply top and bottom by root 3. Well, I'm done playing with that one. But that's it. Good question. You do sine over cosine. So, and what about the other three tricks? Cosecant, cotangent, and secant. They're all, have you noticed they all just come from sine and cosine? They're all just made out of sine and cosine. Sine and cosine are trick. All the rest are just Johnny-come-latelys, right? Tangent is just made out of sine and cosine, right? It's just sine over cosine. Cotan is cosine over sine. Secant is 1 over cosine. Cosecant is 1 over sine, right? So you would just grab. So if I give you the rules for sine and cosine, the rest comes from that, doesn't it? Good question. Make sense? We good on that? Getting all this? All right.